Indicator 23 now, and indicator 23 is all about coordinate graphing, okay? So you can see our learning target, it covers a whole lot of things in this indicator. I can plot rational numbers on a coordinate plane, okay? I can locate and describe as a reflection ordered pairs in the coordinate plane when opposite signs are used. Okay, so we're going to do reflection over here. You can be reflecting on the x or the y axis. Okay, I can graph in all 4 quadrants of the coordinate plane to solve real world and mathematical problems. So graphing, definitely you've got to know. And I can analyze 2 points with a common first or second coordinate to find the distance between them. So these are all my learning targets in indicator 23. Vocabulary, well, we can see the ones I've written down over here. So I'm going to walk you through what these are. Okay, so a coordinate plane is basically formed by the intersection of a horizontal number line and a vertical number line. So horizontal, horizon, this is how you sleep. That's horizontally, and it's also called the horizontal number line is also called the x-axis. And vertically is up, down. Okay, so we stand vertically. And so that is also called your y-axis. So it's formed by the intersection of a horizontal. So here we go. This is horizontal. And this is also called the x-axis. All right. And then we have the vertical, which goes up, down. And this is called the y-axis. All right. The number lines intersect at the origin. So this is your origin. Okay, where the ordered pair is always 0, 0. And we'll talk about ordered pair in a minute. Okay, so when I have a number line like this is 0 on the x-axis, and this is also 0 on the y-axis if I was going up. And then to the right of 0 on a number line, you know we have positive numbers. And then on the left, we have negative numbers. On the top, above the ground level, remember, is positive. Please write these at equal distances. And so put that line and please write the number to the left. So this would be this would be 1, this would be 2, because these are all positive on the top. So 4, 5, 6, 7, 8, and so on. And when we go down, that's underground or underwater, as you can think about it. So we are going below, so that's under, which is negative. So -1, -2, -3, -4, -5, -6, -7, -8, and so on. Okay? So this is how you always have to label it. Numbers should not be hanging in space because we don't know where you have plotted it unless you have it all written out properly. Okay? If you are using intervals, if you are using 2, 4, 6, 8, then everything should be 2, 4, 6, 8. You cannot change intervals. If you're using 5, 10, 15, 20, it will be -5, -10, -15, -20. Okay, and so make sure that your intervals remain the same. Okay, now as you can see, once the horizontal and the vertical line are intersected by the origin, you can see that we have this divided into 4 different regions. And think about when I say quadrant, it has the word quadro. Okay, quadro means 4. So there are 4 different sections over here. There are 4 regions, and these are called the quadrants. Okay, you always start at the top right because this is positive, positive. So here this is my first quadrant. So this is quadrant, and you write it in Roman numerals, quadrant 1. And when I look at the ordered pair, which is a pair of numbers that is used to locate a point in a coordinate plane. So it's a pair of numbers which comprises of a positive and well, it could be positive positive, it could be positive negative, it could be negative positive, negative negative. So, but it comprises of the x coordinate and the y coordinate. Okay, in quadrant 1 we have both positive. The x and y are positive. Okay, then this goes counterclockwise. Okay, this is clockwise, so this goes counterclockwise, the other direction. So this is quadrant 1, this is quadrant 2, and over here your ordered pairs are negative, positive. Okay, negative, positive. And then we have quadrant 3 down here. Remember, it's going counterclockwise. This is quadrant 3, and here but the ordered pair are they're both negative numbers. Okay, and then we have quadrant 4, because we said there are 4 quadrants. So this is quadrant 4 written in Roman numerals, and over here my x is positive, y is negative. So the ordered pair is positive, negative. Okay, so what I'm saying, what I mean by ordered pair, ordered pairs are formed by the x coordinate and the y coordinate. Okay, so if I say 4, -2, if I write this, all right, the first, remember, x always comes before y. So the first number in that ordered pair is your x coordinate. All right, so this is my x coordinate, and the second one is always the y coordinate. Okay, this is in the ordered pair. Okay, and this is used to locate a point in a coordinate plane. Please remember, x before y, or I know in the younger grades you've heard you have to walk to the tree before you climb it. Think of the y-axis as a tree. You have to first walk on the x-axis. You can't just start climbing first, guys. Okay, as a human being, you walk first, then you climb. So remember, x before y, or walking before climbing. So always look at the x-axis first, okay? So if I say plot 4, -2, like I've written over there, this is called an ordered pair. The first one is the x coordinate, second one is the y coordinate. So now if I was going to plot this, I would look at x first. So I look at, okay, I have 4, which is here. So I'm going to go on x first. So here is 4. Then I'm going to look at y, which is -2. So -2 after that is down here. So I go 4, and here on the y we have -2. And so this is my 4, -2. All right, and look what I wrote for quadrant 4. My x is always positive, my y is always negative. So look, positive, negative. Okay, so if I give you certain points to graph, let's say I give you, go ahead and if you are graphing, let's say 2, 3, if I give you -4, -5, if I gave you, let's say I give you -2, 1. Okay, so these are the 3, and well, I can also give you 0, 0. So these are the 4 ordered pairs. I'm showing you how to graph. Okay, actually, let me give you another one, which is, for example, 5, 0, because this is the one you make mistakes on, and then I'm going to give you 0, -6. Okay, so let's plot these. First one, 0, 0. Okay, which is the origin. So If this is 0 on the x-axis, this is 0 on the y-axis, this is the simplest thing. This is what you do, 0, 0. And then please write your ordered pair next to it. So here we go, 0, 0. Okay? If I was graphing 2, 3, so I would go on x first. This is 2. And then I would go 3 is also positive. So this is 3. And here is my point. Okay? Do not climb before you walk. That means do not count 2 here and 3 here because you will get a totally different ordered pair which is incorrect. Okay? So you will see the x-axis first and then the y. Now, if I've given you negative 2, 1. So here's negative 2 on the x and then I have 1 which is up here. Okay? This is negative 2 and this is 1. This is where they meet over here. So this is my negative 2, 1. Okay? Now, if I say negative 4, negative 5. So x first. So this is negative 4. And then it says negative 5. So here we go. And where they meet, this is my point. And this is negative 4, negative 5. Okay, then let me show you these two because these are the ones where you normally make a mistake. So you want to be careful. If it says 5, 0, which one am I looking at first? X. So this is X, remember, this is Y. Okay, so on X, I'm going to go to 5 here. And then 0 on the Y-axis is anything which is right on the line. So 5, 0 would be what? It would be over here. So this is 5, 0. Okay. Now look at the next one. It is saying 0, negative 6. So this is X, this is Y. So 0 on X is here. And then on Y, it's saying to go to negative 6, which is going to be over here. Okay, 0, negative 6. So be careful with these ones. Okay. Now, it might ask you a question like, let's say you've plotted 2, 3, and you've got to know which quadrants these are in. So if it says, what quadrant is 2, 3 in? So I know that both are positive, so that's going to be quadrant 1. So remember, this is both positive, and here it's both negative on the opposite side across. Okay, and then if this is negative positive, across we have positive negative. So think about it that way. So if I say what quadrant would my negative 2, 1 be? So I know it's negative and then 1 is positive, so that would be up there, which is quadrant 2. So on plotting, you should be able to know and identify what quadrant the ordered pair is lying in. Okay, so this is what the ordered pair and all that kind of stuff, the coordinate graphing is. Now we are going to go into reflection. Okay, we're going to go into reflection. So let me erase this much. And I'm just going to erase this. I'm just going to use the same graph so we are not wasting time. And I'll just forget this and forget this and forget this, okay? So now let's go ahead and let's say I give you certain problems, and in that then I ask you to reflect it on either the x-axis or I ask you to reflect it on the y-axis, okay? So you can reflect ordered pairs on any of the axes, all right? So basically, let's do, if I give you 2, 1. So if I'm giving you 2, 1, and I say reflect it on the x-axis. Okay? So first you go and plot 2, 1. So this is 2 and this is 1. So this is my ordered pair. Okay? Reflection on the x-axis means this is x. So think about what we talked about. My 0 is the mirror, right? Whatever I do if I take 1, the opposite of 1 is -1 because it's a reflection. So in the same thing, when I have an ordered pair and I'm saying reflect it on the x-axis, okay, so here is my x-axis. So I have to have the same distance on the other side of x. So it's going to be 2. So you can see that this is going to stay the same. The x stays the same, all right? But my y is going to change because the same distance, but on the other side of the x. So look, that's a reflection, all right? So this is reflected on the x-axis. My y changes, but my x stays the same, all right? So this is x-axis reflection, okay? Let's say I had to reflect this on the y-axis, okay? Now this is my y-axis. So if I was reflecting over here, remember what I said, it is 2, 1, okay? So if I'm reflecting on this side, my x is going to change because this becomes -2, but y will stay the same because look, I'm reflecting it on the y-axis. This is y. So from 2, from 0 to 2, I have 2 units. Same thing, from 0 to -2 is 2 units. And then I go up the same amount because look, isn't this a reflection? But on this side, same distance, but on the other side. And so this is going to give me -2, 1. So just be careful about where it's asking you to reflect so you know what the ordered pair will be on the other side. And remember to reflect a point in the x-axis. The x coordinate remains the same. So look, x remains the same. The y is the one that is negated, okay? And to reflect a point in the y-axis, the y coordinate is going to stay the same. Okay, depends on which side you are reflecting. That side x will stay the same, this side y will stay the same, and then the x coordinate is negated. Okay, so let's go ahead and let's say I give you 4, 5. So if I give you 4, so I go to 4 first on the x, and then I go up. Okay, so this is my 4, 5, and I say reflect it on the x-axis. So remember, if I'm reflecting on the x-axis, it's still going to be 4. My x is going to stay the same. It's just the y that will change. So I'm going to go here and the same distance, which is 5 units. So this is going to be 4, -5. Okay, so this is on the x-axis. This way, this was on the y reflection. This is the y-axis reflection. Okay, when it is reflecting on the y-axis, on the vertical line. So if I'm saying 4, 5, and I need to reflect that on the y-axis, remember y would be the same, the x would be changed. So if this is 4, 5, I'm going to go that distance from here. So this is 4 units, this is 4 units. So this is -4. And then I would go up and I would get here. So this is -4, this is 5. So this is reflection on the y-axis. This is reflection on the x-axis. All right, so it has to look the same thing on both sides at the same distance, and that's what reflection is. Okay, so let's say I give you a -2, -4. So -2, I look on over here first, and then I go down y. So this is -2, -4. Okay, and then if it's asking me to reflect on the y-axis, okay, so if I'm reflecting this on the y-axis, I am going to reflect on this. So therefore, here, same this is 2. I'm going to reflect off that. So this is 2. I'm going to come down here, and I am going to go here. Okay, so it's going to become 2, And of course, the y-axis remains the same. So I just wanted to show you what x and y reflection is. Remember, for x reflection, you are going from top to down or bottom to up. So you are going this way, reflecting. For the y-axis, you're going from side to side when you're reflecting, okay? So that's what reflection is. Now, next thing is to find out is the distance between these points. And if I say how far apart are the points with coordinates, so I'm going to remove the reflection, I'm assuming. Yeah, we can move on. So let's say it asks for reflection. No, it asks for how far apart are points with the coordinates 2, 2 and 8, 2. All right. And then also, what quadrant does this lie in? So just looking at those, I can automatically know that the quadrant is definitely going to be quadrant 1, because whether I say 2, 2 or if I say 8, 2, when I'm finding the distance, both are x and y coordinates are positive. So these are going to be graphed on quadrant 1. Okay. So let's graph 2, 2. So this is 2 and this is 2. Okay, and then I look at 8, 2. So here's 8 on x first, and then I have 2 over here. So now it's asking, what is the distance between these? Okay, now this is pretty clear cut, guys. All we're doing is you're going in the same coordinates, so you're looking at, okay, what is the absolute value of 8? And you're taking away absolute value of 2, or you can just count from here, from 2 all the way to 8. 1, 2, 3, 4, 5, 6. So that is 6 units. Okay, that is 6 units. So that's how far these two are going to be. All right, you're just counting how many units are over there. Or we know that your y coordinate is the same. So if I took the absolute value of 2, I get 2. Absolute value of 8 is 8. And I did 8 minus 2. And I get 6. So that is 6 units. Okay, now let's try. And of course, this is lying in quadrant 1. Okay. Let's see, I give you a problem in which how far apart are points let's say I give you -1, 4, and then I give you -9, 4. Okay, so when I'm seeing it's negative positive, I know that this is definitely going to be on my quadrant 2, because if it asks what quadrant is this going to fall in, so it is definitely going to fall in this quadrant here. Okay, I'm going to try to just, it's -6, -7, -8, -9, and I am just going to move this a little bit so you can see what I'm doing. All right, and so how far apart are the points over there? So if I was plotting it, I know that -1, 4, so this is -1 on the x, and here is 4 on the y. Okay, so this is my -1, 4. And then I have -9 here, and then again I'm going up 4. Okay, so this is my -9, 4. And then you're seeing what is the distance or how far apart are these points. So you can count from here to here. Okay, you can definitely do that. And then because that's basically what this is, from -1 to -9. So this is 1, 2, 3, 4, 5, 6, 7, 8. So this is 8 units apart. Okay, or I could do the absolute value of -9, which is 9, minus the absolute value of -1, which is 1. And so then I end up with 8 units, okay, because the y coordinate is the same. All right. If I do one, well, Again, this would be in quadrant 2. And then let's do one more. Trying to see if I have a negative and if I have a positive one, because trying to find a problem. Okay, so let's say how far apart are 3, 6 and negative 4, 6. All right, so if I give you something like this, so let's plot it first. So this is 3 and here is 6. Okay, so this is my 3, 6, which is already written here. And then I have negative 4, 6. So we're going on this side. Okay, and then 6, which is up here. So this is negative 4 and this is 6. Okay, so we're trying to find what is the distance over here. What is this distance? Okay, so in order to find this distance, guys, in this one, because they are on opposite sides of the y-axis, we're going to take the absolute value and add it. So absolute value of 4, a negative 4 is 4. Absolute value of 3 is 3. So this would going to be 4 plus this 3 over here, and which gives us 7. So this is going to be 7 units. Okay, so this is how you calculate the distance. Another thing, there is definitely a formula for this, but you learn that in 8th grade. But when you're in my classroom, I can give that to you. I just don't want to overwhelm you and confuse you on the video. But the simplest way is just to look at, the absolute values and see the distance from one to the other, and then calculate how many units are over there. Remember, reflection is going to be either on the x or the y axis right now. And so if it's saying x axis, you have to reflect top to down or down to up, okay, or down to top. If it's saying reflection on the y axis, this is the y-axis, so you are going from left to right, right to left, so right across like this. Okay, so that is the reflection. Make sure that you understand where the ordered pairs are located, which quadrant. And then the easiest way to do that, just think about it. The top right is quadrant 1, where you have positive, positive. When you have negative, positive, it's quadrant 2. Negative, negative is going to be your quadrant 3. And positive, negative is going to be your quadrant 4. So it's really easy. And when I'm saying positive, positive, that means the x is positive, y is positive. Okay, if I say x is negative, y is positive, that is quadrant 2. So that's what when I say positive, positive, negative, positive, all that kind of stuff. Okay, so anyway, this is graphing, and I know we do a lot of fun graphing stuff in the classroom, like Thanksgiving, Easter, Christmas. I have all kinds of cool stuff when we are in the classroom together. All right, guys, have a wonderful day, and that concludes indicator 23.